could just make mistakes or whatever. Okay. All right, here. Presenting two variable data. As with other types of data, two variable, right? 1, 2, an x and a y, independent or dependent, all right? Can be presented in various ways and formats that can emphasize different characteristics of the data. Sometimes the presentations are intentionally misrepresented. Politicians like to misrepresent. Intentionally designed by the author or by the media to be misleading. Sometimes they just make mistakes by accident. When analyzing two variable statistical summaries, you should be aware of the following factors and techniques that may represent true relationships. Sample size is too small to represent the population. Right? Look at this sample. 1, 2, 3. 3? That's a sample? That's not a sample. The sample is biased, so it does not represent the population. Right? Somebody might just have picked their friends or something. A line of best fit is given without a correlation coefficient, so there's no way of knowing how well the line data fits the line. So that's your R calculation, right? Scales on the axes are stretched or shrunk. Look at your x-axis here. Look at your y. This is compressed and this is stretched. I wonder why. There are other variables that affect the statistics that are not part of the data, but they're still very important, and you need to know that word, extraneous variables. Right? The data may represent an accidental relationship. Well, what is an accidental relationship? Well, watch. Let's say here, as the population of Italy increases, the population of York Mills Collegiate increases. So it goes like this. Now, how would you explain it? Well, it's accidental. Maybe there's a common cause factor like increasing populations in general. Italy's population is going up, so York Mills Collegiate population is going up because people are having babies and the population is growing. So, however, sometimes it's just accidental. It's just by accident. It's not really a true relationship, even though R is strong. The data summary does not give a comparison to a, so there's no control group, right? There's no control group here. That's always helpful. So let's just analyze this little ridiculous little case study. And I call it ridiculous because it's a little bit ridiculous. So, if we were just to go down this list, what do you think of the sample size? Right. Sample size is too small. Too small. Sample size is too small. 2. The sample is biased. Well, Sonia is trying to...
I think this will really depend on what math course it is.
That's very true.
Calculus and vectors will probably be spending less time on the computer anyways.
Yeah, that's a good point. Okay. So that might be, would you say, you're probably saying we need some kind of control. What can you say, would you say the sample is biased?
She's just serving the students in her class,
Oh, okay. Yeah, we don't know how she selected her sample. Sorry? This is true. So there's a bunch of extraneous variables here. I'm just getting the points down in a row. We'll mention that one in number 5, okay? Different type of teacher. So we don't know how she selected her sample. It may be just her friends, you know, a very biased sample. It may include only her friends or whatever. Okay, the line of best fit is given without a correlation coefficient. Do we have one? And you know, just the way she drew her scale, you can make any points look like they fall on a line. So number 3, there's no R. And we do not know how closely the points fall on a line. Okay, number 4. Let's see if we can fit it in here. Okay, number 4. So the scales on the y-axis, the scale on the y-axis is shrunk. The scale on the x-axis is stretched. This makes the points appear closer to the line. This makes the points appear closer to the line. And I kind of, all right, can I read that for you? The scale on the y-axis is shrunk. The scale on the x-axis is stretched. This makes the points appear closer to the line. Number 5, you're right, extraneous variables. Or did they say it's all from one class? Oh, so extraneous variable. So there's only one teacher teaching it, so the issue of different teachers I don't think applies here, right? Because it's all from one class. Can you give me an example of?
But wouldn't like in a school, your population, this sample wouldn't represent your population is the class.
Right, it would and I wouldn't. Yeah. Plus, there on top of it, there's extraneous variables. Can you think of any?
How something does that?
Parents' occupation? I don't.
Maybe some people do their math homework on an iPad and then they count that as computer time.
Oh, maybe homework on iPad. Because now you can write on your iPad, right?
Cheap of $120.
Huh?
For a cheap price of $120.
Any iPad? An iPad for 120?
No, to write on it with like a pen.
Oh. Oh, the pen is 120. Whoa. Any other extraneous variables? Did somebody mention quality of study? IQ, yeah. IQ's an issue.
Time to go to sleep.
What about hours spent studying? Oh. And also, you know, how well they're rested was mentioned. You don't know what they're doing on the computer. I guess that ties in. You could be doing homework. You don't know what they are doing on a computer.
Those 4 hours of going on the computer was watching that video.
Oh,
That's sad.
That's sad.
Khan Academy.
Or Isabel Kosinski's YouTube channel.
Oh yeah, Kaczynski's YouTube channel.
Yes.
It's very tight. Can I read it? Extraneous variables. Some people might do the homework on an iPad and count that as computer time. A person's IQ, hours spent studying, how well the student is rested. You don't know what they're doing on the computer. I'm not sure if we need it. There's no issue of there's no control group, so
Basically, it's a very bad graph.
it's a bad graph. And it may be accidental. The relationship could be accidental, right? The relationship could be accidental. 6 over here. Are we good? Okay, I'm going to sign off.